All right, so our log equations, we're going to use strategies. So we will use our strategies to solve. Okay, a log equation is an equation with a log expression that will have a variable, kind of like our exponential equation had an exponential function, okay? So here's our strategies. Here's what we're going to do. We can solve log equations by using the properties, okay? So that will be one of our strategies, okay? So solving the log equations by using the properties of our logs, that means we are condensing them, okay? That means we are making them into a single log. Okay. The other thing we had on our warm-up was our power property, right? We can use our power property as well. So we can combine to a single log, and we will also make use of our power property. I ran out of room, sorry. Once we have accomplished a single log, either by using our condensing them by using our properties or by using our power property, then you will have a couple of options. These will be your options. You can continue to solve the log equation by applying our inverse property. And that was our second slide on the warm-up, those three that were on the warm-up, how our bases canceled each other out, okay? Or you can choose to just take your equation and rewrite it back into exponential form, and then you would proceed as you would to solve exponential. Okay? And our last one down here, sometimes they will give you an equation where you have the log on each side. Log base b of x equal to log base b of y. Think back to our strategy with our exponential equations. When we had the same base on each side, what happened to those bases? They canceled out. So if you have a log that has the same base on each side, that process still works the same. They will still cancel each other out, just like before, and then you would just have what's inside or what's embedded in the logs, and then you would proceed to solve. Okay? And you won't have an x and a y. You'll just have your x, of course. But so there's your options for solving our log equations. Okay, so we went through everything, I think, for the most part on the warm-up, combining our logs, working with our power property, and working with our inverse. Okay? Any questions before we move on? All right, when we are working with log equations, sometimes we will get extraneous solutions. Those extraneous solutions are solutions that we may have gotten it when we solved the equation, but if we were to sub that back in, that it would not make our original equation true. Okay? We did not have to do this with our exponential equations because we did not have a limited domain. Look up here for me real quick. Remember with your exponential function, our domain was all real numbers, right? Went from negative infinity to positive infinity. But when we are working with our log equation, our domain is restricted, right? Our domain has to be what? Is this our asymptote for our log? So remember that your x values can only be what? What are our values over here? Greater than 0. Okay? So we are restricted sometimes, and sometimes we will get an extraneous solution for the fact that remembering that your log function domain is limited to those x's, greater than 0. So I'll write that down up here so we can reference back to that. So for your log, we are limited to values of x that are greater than 0 for our parent. Okay, so let's take a look at our first example here. We have, well, this is kind of nice. It's kind of nice because do we have to combine anything? Or do we already have a single log?
I think single already has
Why do you think that? Because you only see one? Yeah, I would agree with you on that. Okay. All right. So we're actually ready to we're actually ready to solve this, okay? And I gave you two options to solve this. You can either solve this by using an inverse property, or we can rewrite this as an exponential. What do you want to do? We'll do both of them. What do we want to do first?
inverse property.
Inverse property. Okay, let's do that first. So if that's the case, so here's what you do. That x term is embedded or inside the log, right? So we can't get to it. The only way we can get to that x at this point in time is we have to get rid of that log base 4. So if I have a log base 4, what could I introduce into the equation to get rid of it? Yes, very good. Another base of 4. So that's exactly what we're going to do. So we're going to bring in a base 4 to both sides. Now understand when you do that, when you bring that in, what you already had are now exponents. Okay? These are now exponents when you bring that in. Oops, can get it to. Okay? So now here's your inverse property kicking in, right? So this base 4 cancels out this log base 4. You see it? Think back to what we did on the warm-up. So this base 4 cancels this log base 4. So now all I have left over there is the 3x minus 1 equal to a 4 squared. What is a 4 squared? 16. So I'm going to take that off, and I'm just going to put a 16 where I got it. Now you can solve this, right? What are we going to do? We're going to add 1 and then divide by 3. So if we add 1 and divide by 3, that's going to leave us with
15.
17 over 3.
Oh yeah, you're adding almost right.
yeah, so yeah, you have to add him, so it'll be 17. Okay, so if we were to rewrite this, my base is 4. What's my power?
2.
And my A was the 3x minus 1. Okay, so do you see where they're coming out to be the same? So my 4 squared, here's my 16, equal to the 3x minus 1. See how they're matching up? And then all you would do then is proceed to solve this one as well. So we would do what again? We'd move the negative 1 over as a positive 1, giving us 17, and then we would divide out the 3. Okay, so this one was rewriting, and this one was taking the inverse. Okay, so here's your two options that you can take. All right, so we're going to take the 4 times the natural log of 3x equals the 8. So first thing we need to do is get that 4 out, so we'll divide it out. So natural log of the 3x equals 8 divided by 4? 2. Okay, so now we're going to go ahead and instead of rewriting this one, we will just take the inverse. So I need to get rid of a natural log, and we get rid of natural logs by introducing its inverse, which is the e. So we'll introduce the e into both sides of the equation. Remember what I said previously. When you introduce a new base, remember those become the exponent or the power. So your e and natural log, those guys cancel each other out. So they're out. So we have our 3x equal to our e squared. So e squared was, what was it in your 4 something, or it was, I don't have it down. 7.6. Okay, so you put that in the calculator, and then your last step is just to divide that 3 on out of there, and it was look back over here. It was 2.46, rounded off. Everybody knows how to get the e squared in the calculator. Remember, it's the natural log. Okay. All right. We good?
Yes.
Okay. All right. So let's look at our next one. Let me change color. Let's go with purple. All right. So this is different from the first one in that you have log base 3 on each side. It's nice that they both have a base 3 because what happens to bases that are the same? Cancel. So these just cancel each other out. And now we have a nice, oops, not 3. We have a 2x minus 3 equal to an x plus 4. Okay. What's your first step going to be on this one?
Subtract the x.
Yeah. Remember what I've told you? Always get your x first. Always take care of the x first because that will keep you from making a mistake after that. So that way, if we move that over, that's going to give us an x, right? So we would have x minus 3 equal to 4. So x is going to be 7. Okay, so let's do that. All right, so when you look at this, you should notice that you have that power of 4. So we're going to go ahead and move him onto the front and make him a multiplier. So we're going to have 4 times the log base 5 of x equals 8. Now what are you going to do? Then you're going to do what? Not yet. Yeah, what are we going to do? Yeah. So now then, since he's a multiplier, you need to get rid of him and you can divide him on out of there. Okay? Very important step, so don't forget it. So if we do that, that would give us log base 5 of x equals what? 2. Okay. And you can choose to bring in a base. Most of you were doing the inverse. Let's just, what do we need to bring in to get rid of the log 5? Let's bring in a base 5. So if we bring in a base 5, that 5 will cancel the log base 5. So we would have x equal to what? 5 squared, which is...
I like this a lot.
Okay. Yeah, they're not, yeah, as long as you get them. They're not bad.
What's the other way to do it?
We could have rewrote, okay, so the other way would have been log base 5 of x equals 2. You have a base of 5 raised to the power of 2 equals x. That's the rewrite. Okay. So in this case, when the logs are on the same side of the equation, so here's your equal sign, right? They're on the same side of the, yes, that's where we need to combine them. We need to bring them together.
Are you able to put one at the other side?
No. No, you don't want to do that. No, we're going to go ahead and combine them. This is a plus, so how are you going to bring them together? Multiply. All right. So if we bring them together, we're going to have log base 2 of x times our x plus 2, and keep that in parentheses, equals our 3. X times x plus 2 would be?
X squared. X
Squared plus 2x.
Okay. So now we're back to what we had previously. However, we do have a quadratic this time, so this is where our extraneous solutions will be introduced if we have any. So do you want to just bring in your log base 2?
Yeah.
Okay. So let's bring in a base 2 so we can get rid of our log base 2. So those will cancel out. So we'll have, I'm going to scoot on up here. I'm running out of room. So we're going to have x squared plus 2x equals, what is 2 to the third power? 8. All right, guys, this is a quadratic. How do we solve quadratic functions? We can use the quadratic formula. We can set, yes, thank you, Kimberly. Yes, first thing we need to do is set it equal to 0, right? Yeah. So what would we do? Move the 8. Okay, so let's move him over. So we would have x squared plus 2x minus 8 equals 0. Now what are you going to use? You want to try X method? Yeah, let's always try that first. If that fails, then we always have our quadratic formula to fall back on. So let's see, our C is a and our B is a 2. So what combination is going to work for you? Positive 4, negative 2?
Yes.
Okay, so let's put that in. Okay, so x plus 4, x would have to be a negative 4. And over here, x minus 2, x would have to equal a positive 2. To the what? So you remember our domain for logs have to be what? Greater than 0. So what's going to happen if I do this? I'm going to come back up here. So I'm going to introduce the negative 4 back in. Log base 2 of negative 4 plus log base 2 of negative 4 plus 2 would be negative 2. Okay? Can my x be a negative value in my log? No, right? Because of our asymptote, we cannot have negative values. So what does that tell you about your negative 4?
It's wrong.
It is an extraneous solution. I can't get it to. It is an extraneous solution, so we will throw it out. Okay? And we will not use it. Check your 2. Can we have a log base 2 of 2? Yes. Plus a log base 2 of 4? Yes. What is log base 2 of 2? No. What do you raise 2 to give you a 2? 1. Plus, what's 2? There it is. So that one works. Okay? So negative 4 was extraneous. Your 2 was the correct answer.